Good morning, children. So last classல நம்ம self induction அப்படின்ற ஒரு டாபிக் ஸ்டார்ட் பண்ணோம். So self induction we discussed after the eddy currents. So eddy currents we know in some cases it is giving more applications and some cases it is giving undesirable things to us. Okay, அதை முடிச்சுட்டு அதோட applications பார்த்துட்டு we discussed about self induction. In the self induction number of turns irukku coil whenever we are passing the electric current, that produced magnetic field will produce some induced EMF in that same coil itself, that will oppose the source which is using to produce the electric current in that. Okay, நம்ம பார்த்தோம். So other unit நம்ம இப்போ படிக்க போகிறோம். The unit of inductance, it is nothing but a scalar. So what type of unit? It is a scalar. We know about scalar. Scalar means it having only the magnitude, there is no direction in this, and its unit is taken as Weber per ampere or Vs per ampere. It is also measured in the term of Henry. So in the three units நம்ம எதை வேணால் யூஸ் பண்ணிக்கலாம். 1 Henry is equal to, we can write as 1 Weber per ampere, so 1 volt second per ampere. Okay, and the dimensional formula of inductance we are giving m L power 2 T power minus T A power minus 2. Suppose if the current value is 1 ampere means then n phi b will become as 1 Weber per turns. Then the L value, the inductance value will become 1 Henry. So here we can define the inductance of the coil is 1 Henry when the current is flowing through the circuit is 1 ampere, through that coil is 1 ampere, and it produces the flux linkage of the coil is unit value means that is called as 1 Henry. Okay, that is called as 1 Henry. That we can write with the formula di by dt is equal to 1 ampere per second, and epsilon is minus 1 voltage. Then inductance produced in this is 1 Henry. Okay, the inductance of the coil is 1 Henry if a current changing the rate of 1 ampere per second. So the rate is di by dt. It is changing the rate of 1 ampere per second means the induces an opposing EMF is 1 voltage in it. Then it is called as inductance of the coil. Its value of the inductance of the coil is 1 Henry. So we can define in two ways. Okay, so rate with the rate of current we are defining, then we are defining with the unit current which is flowing through the coil. And after that, here we'll discuss about physical significance of inductance. So while discussing this, we are recapturing the 11th standard unit. So from the unit number 3, we discussed about translational motion. So mass is measured in linear inertia. In same way, the rotational motion is discussed in moment of inertia. That is called as rotational inertia. And this inertia is nothing but its opposition to change its state. So we discussed about this in 11th itself. So based on that, we are going to explain how the induced EMF is opposing the source which is producing it. That only we are going to discuss in this. And see, for that we having two figures, figure 4.19a then b, and see the first figure a. So it is connected with the EMF, and the current direction is given. See in a, the current direction is given here. The produced EMF in this coil is acting opposite to that current, so it is opposing. So when a circuit is switch on means the increasing the current in this circuit will induce some EMF in the coil, and this EMF which is opposing the growth of current in a circuit. Same time, when we switch off the battery, we can say that is circuit is broken. Here the current is decreasing. This decreasing current induces an EMF. This EMF will be reversed as compared to the previous position. Okay, now this EMF is opposes the decay of current. It is explained in figure B. Okay, children, and see in both the figures the symbol of positive negative is reversed. So when it is reversed, now this produced induced EMF, induced current, induced EMF will oppose. So நம்ம increase பண்ணும்போது increase ஆகிற directionலையும் decrease பண்ணும்போது அதுக்கு opposite direction it is try to decay, and the EMF now opposes the decay of current, and we can say the inductance of the coil opposes any change in current and tries to maintain the original state. This is a special character of this induction, the self-inductance. Okay, and now we are applying this explanation for long solenoid. So for what we are studying here, we are discussing for long solenoid. So the topic is the self-inductance of a long solenoid. We are going to calculate the self-inductance of this long solenoid. So first we are explaining here. So அதுக்கு முன்னாடி இந்த டேர்மை ஞாபகம் வச்சுக்கோங்க, NaIL. ஸோ இது நம்ம எப்படி சொல்லலாம், நெயில் சொல்லலாமா, நெயில் ஞாபகம் வச்சுக்கோங்க. இதை வச்சுட்டு இந்த ஆன்சரோட இன்ட்ரோ நம்ம கொடுத்துடலாம். ஓகே, NaIL, நெயில். ஜஸ்ட் உங்கள் புக்கில் இந்த ஆன்சர் பக்கத்தில் நோட் பண்ணி வச்சுக்கோங்க. இது ஜஸ்ட் ஃபார் ரிமெம்பரன்ஸ். எக்ஸாமில் வந்து இது எழுதுனா உங்களுக்கு மார்க் கிடைக்கின்றது இல்லை. இட் இஸ் ஜஸ்ட் ஃபார் ஒன்லி ரிமெம்பரன்ஸ். இது புரிஞ்சிச்சுன்னா யூ கேன் ரைட் திஸ் ஆன்சர் வெரி ஈஸிலி. Okay, and now here we having the solenoid. So the perfect solenoid means it should be very long. Okay, if it is long, that is called as perfect solenoid. That solenoid having the length of L, and that is here given, and its area of cross section is capital A, and n number of turns are there in the solenoid. When an electric current I, புரிஞ்சிச்சா, length of the solenoid, number of turns in the solenoid, area of cross section of the solenoid, when the electric current is passing through, that is called as I. So all this combiningly only I wrote as NaIL. Okay, it is easy to explain this intro. And see, in this we are when the electric current is passing through, a magnetic field produced inside the solenoid, it is almost uniform, and this direction is along the axis of uniform solenoid, axis of the solenoid. About the solenoid we discussed in unit number 3. Okay, the magnetic field at any point in this inside the solenoid we can write with the formula. So for this we have to refer the topic 3.9.6 or check your page number 165. Third unit la 165th page la நம்ம அதை derive பண்ணியிருக்கோம். Then that equation is written here directly. So the equation is written as directly, capital B is equal to the magnetic field produced in the solenoid is B is equal to mu naught Ni. So what is the equation we discussed here? Mu naught N into I. Okay, and now the magnetic field is passing through the solenoid. The windings of solenoid are linked by the field lines. So field lines are linked with these windings. Then there is a production of magnetic flux. That magnetic flux is passing through each turn. We can write with the formula phi B is equal to, so what formula we are using to show the magnetic flux? Phi B is equal to integration of area B vector dot dA vector. This is basic formula for flux. In the unit of starting la நம்ம படிச்சிருக்கோம். So what is the equation? Integration B vector dot dA vector. Then we are expanding, this is dot product, then we are writing BA cos theta. So say the theta value is 0 degree, then cos 0 is 1, then this value will become as BA. Okay, then we are substituting the B value from the previous equation. We are substituting this B. What is capital B? Mu naught Ni. Mu naught Ni into A. So we got the new equation for flux, mu naught Ni into capital A. Okay, and now we are going to calculate the total magnetic flux linked or flux linkages in this solenoid, which having the n number of turns. So n number of turns means capital N we can write as n into small l. So small n is what? It is number of turns per unit length. Capital N is total number of turns in the solenoid. Okay, so per unit length solenoid, number of turns per unit length is small n. Then capital N we can write as n into L. Then we are writing the formula for total number of turns. இது வந்து single per unit length நம்ம எடுத்துக்கிட்டோம்னா total number of turns we can write இதே formula கூட we can multiply with the n. So the same flux is multiplied with capital N. Then this equation comes n phi b is equal to, then mu naught Ni இருக்கா, இது வந்து for per unit lengthக்கு, அப்போ total length அப்படின்றப்போ n into L. So n இதே formula இங்கே எழுதுறோம், nL mu naught Ni into capital A. Children புரியுதா? Okay, good. And next நம்ம இதை combine பண்ணுறோம். n phi b is equal to mu naught n square capital AL into I. Mu naught n AI n square AL into I. இந்த equation எப்படி இருந்துச்சுன்னு உங்களுக்கு நல்லாவே தெரியும். And we know that for self-induction in equation 4.8, Okay, in equation 4.8, previous page 212 in the equation we found this n5b is equal to li. சரியா? n எல்லார் கையிலையும் புக் இருக்குன்னு நினைக்கிறேன். ஸோ ஜஸ்ட் யூ ரெஃபர் வித் த புக். n5b is equal to li. And now we are comparing both the equations. About two equations. Last two equations பாருங்க. These two equations having the same left hand side. Then we are equating the right hand side of the above equations. So when comparing this, we can write the equation L is equal to mu naught n square AL. This is 4.10. And from the above equation, we can say it is clear the inductance of geometry of the solenoid is depends on the turn density and cross-sectional area A and its length is L. And the medium present inside the solenoid, it depends on that. If the solenoid is filled with the dielectric medium of relative probability mu means the equation, the above equation can be written as L is equal to mu. So what is the difference here? We know mu is equal to mu naught into mu r. So what is mu? Mu naught into mu r. So here it is mu naught is written here because that mu r is 1. And now we are writing mu naught into mu r in the format of mu. Then equation will become mu n square a into L. Or we can write the equation mu naught mu r n square into AL. Suppose any medium is there means. Have you understood, children? This is what? This is the inductance value. Okay, the solenoid have the inductance value L is equal to mu n square A into L. Okay, and next we are going to calculate the energy stored in an inductor. So what we are going to calculate? Energy stored in an inductor. So here we are going to explain, we are going to discuss about the energy stored in this inductor. We can say whenever a current is established in the inductor circuit, this inductance opposes the growth of the current. Okay, that we discussed in a previous case in the topic of physical significance of inductance. எப்போவுமே அது சேம் லெவலில் மெயின்டைன் பண்ணுறதுக்கு தான் ட்ரை பண்ணிகிட்ருக்கோம். ஸோ இதை ட்ரை பண்ணுறதுக்கு we have to give some work done. The work done should be established there against the opposition by some external agency, and this work done only stored here as magnetic potential energy. So what is the, how it is stored here as magnetic potential energy? And to calculate that, here we are using the formula. So epsilon we can write here as minus L dI divided by dt. We know this equation. Okay, so previously we discussed this. Epsilon is equal to minus L dI divided by dt. And we are giving some work done. So to calculate the total work done, we are taking the small work done is given a small charge. Formula is dW is equal to minus epsilon dq. Okay, and then we know the formula from the second unit. We having the formula I is equal to dq divided by dt, or I is equal to q by t in படிச்சோம். Instantaneous current அப்படின்றப்போ dq divided by dt, and from this dq is equal to what? I into dt. So that formula is used here, and we are substituting the q from the unit number 2 formula is minus epsilon I dt. So what is the formula we got here? Minus epsilon I into dt. Okay, and we are substituting the epsilon from the equation 4.16. So we are substituting what? Epsilon. Okay, so we are substituting the formula epsilon from this equation. So from the equation, the epsilon is here. We are substituting in this minus L di divided by dt. So it is not 4.16. It is not necessary here. So from this previous epsilon, we are substituting in this. Then we got minus of minus L di divided by dt into I dt. Okay, and see the next step. dW is equal to minus into minus will become plus. Then we can write dt and dt get cancelled. And next step we got dW is equal to Li di. Li di. And total work done in establishing the current I we can write with the help of integration. So this dW is for small work done, and maximum work done is we can write after integrating. So maximum work done W is equal to integration dW, integration 0 to t Li di is equal to L of I square divided by 2, 0 to I. Okay, and half will be taken out. Then the rest formula is Li square. Then the total work, this work done is stored here as magnetic potential energy. Then this work done is written as UB. Then the magnetic potential energy stored in this solenoid is UB. To give the work done to restore the electric current in this, that is converted as half Li square. And to find the energy density in this, so what is energy density means energy stored per unit volume of the given space, that we can write here. Energy density small ub we can write as capital UB divided by AL. Okay, capital UB is what? The energy stored. Okay, unit volume is taken as AL. So area into length is called as volume here. And now we are substituting the known terms. After substituting UB, we know half Li square. So this is substituted in UB. So it will become half Li square. It is written here. Okay, and rest AL is written as it is. Then we are expanding the L. So we got the L in previous, before the energy storage, see the 214 first half, we got the L value as mu naught n square AL, that is substituted. Then AL get cancelled, and the next step is mu naught n square I square divided by 2. Okay, and now we are writing the equation. We know B, third unit நம்ம படிச்ச last derivationல பார்த்தோம்ல, B is equal to mu naught Ni. So in this mu naught Ni is taken as B. Okay, and here from the equation we are writing here as it is given as B square divided by 2 mu naught. In the mu naught, இங்க ஒரு mu naught இருக்கிறதுனால we are doing into mu naught and divided by mu naught. The into mu naught will comes in B, and this divided by mu naught is comes in equation. So B குள்ள இந்த mu naught square வந்துரும், because we need for B as mu naught square n square I square. இங்க n square I square இருக்கு, mu naught square இல்லன்றதுனால we are multiplying and divided with mu naught. Then mu naught square என்ன ஆகும்? B square ஆகும். Divided by mu naught is given in this equation. So this equation we solved here. So the energy stored in an inductor, we can say that is in energy density we can write B square divided by 2 mu naught. Right, clear children? So that is the equation we got here. So important question this one. Okay, next after this we are going to discuss about example 4.10. It is a simple example. So if you know the formula, we can get the answer for this. Okay, a solenoid, the solenoid turns is given as 500 turns, is wound on an iron core which having the relative permeability of 800. The length and radius of the solenoid are 40 centimeter and 3 centimeter respectively, and we have to calculate the average EMF and induced in the solenoid, average EMF induced in the solenoid if the current in it changes from 0 to 3 ampere in 0.4 second. So we are writing all the known given datas, n mu naught L, then that L is converted into meter, then R is converted into R value is converted into meter. So centimeter to meter how we can convert? Into 10 power minus 2 போட்டுக்கலாம், இல்லைனா அதை டிவைட் பண்ணி தான் இங்கே போட்டிருக்கான். 0.4 போட்டுக்கலாம், இல்லை 4 into 10 power minus 2 போட்டாலும் it's right. Sorry, 40 into 4 10 power minus 2 is also right. Then the current change in current is we can write as it is changes from 0 to 3 ampere. So change in current we can write as 3 minus 0. Okay, that is equal to 3 ampere. Then dt is equal to 0.4 second. Then we are substituting the self inductance. The self inductance L is equal to mu n square AL. Okay, then mu we can write as mu naught into mu r. We are substituting in this mu naught mu r n square. What is capital A? Pi r square. சரியா, ஸ்மால் nன்றது பார்த்தீங்கன்னா நம்பர் ஆஃப் டர்ன்ஸ் பர் எல், ஆர் கேபிட்டல் N is equal to small n into L. அதிலிருந்து we are substituting the L value here. Okay, after substitution we are solving this. In this we are getting the answer 1.77 Henry. Okay, எல்லாத்துக்கும் உங்களுக்கு தெரியும் நினைக்கிறேன் இந்த டெரிவேஷன், ஒர்க் அவுட் பண்ணிடுவேன்னு நினைக்கிறேன். ஏதாவது டவுட் இருந்தால் ஷூர் யூ கேன் ஆஸ்க் மீ. Next is induced EMF. So for induced EMF we are writing the formula epsilon is equal to minus L di divided by dt. So this is the formula what? Induced EMF is given as the formula minus L di divided by dt. Then we are substituting in this. Okay, L value we know 1.77, and di that is 3 minus 0, and here it is 3 divided by dt we can write as 0.4 second, that is 0.4. இதை மல்டிப்ளை பண்ணி then divide பண்ணோன்னா the answer is minus 13.275 voltage. Okay, this is the answer we got for this question. So we got the average EMF induced in the solenoid, okay, and also induced EMF and inductance also calculated in this. So after finding the inductance, we substitute in that induced EMF. Okay, so have you understood, children? Yes, good children. And for today's homework, see the self inductance of a long solenoid. Okay, you mark the answer. Self inductance for the long solenoid. You can mark the answer this topic up to here. Sharia, including the picture. So this picture also included here. You draw this picture, thorough this answer. After throwing this answer, you write this answer without seeing in your homework part. Your photo edit, you send that photo image to my personal WhatsApp number. Okay, thank you, children.